All right, guys, welcome to lesson 111, applications using division. Can you guys believe how far we are in this book and how we don't have that much to go? It's crazy. All right, so today, applications using division, basically what we're doing is we're looking at different ways to write remainders when we have division problems and how to answer questions when there are remainders. So let's do 3 examples here. We all have these 3 lined up, 15 divided by 4, and let's do 3 different ways to write our remainder. So the first one, 4 goes into 15 3 times with a remainder of 3. So this is sort of the elementary school way to write remainders. We just write R3, that's it. Okay? Another way is 3 with a remainder of 3. We would write that as a fraction. Okay? So our remainder goes on the top and our divisor goes on the bottom. So 3 3/4. And then the third way we know to write remainders is to write them as a decimal. So what we would do is we would say it goes in 3 times with a remainder of 3, but we would have turned this into a decimal, carried that down. How many times is 4 going to 30? 7 times. The remainder of 2. How many times is 4 going to 20? 5 times. Okay, so here are 3 different ways that you can write your remainder. So the way you write your remainder depends on the question that's being answered. Sometimes you may need to also round the answer up or round the answer down. So in this case, our answer would round, 4 would round up. It would round up to 4 because 3 3/4 is closer to 4 than it is to 3, so that would round up to 4. So basically what you're going to need to apply in this lesson is how to very carefully look at the question and answer really what's being asked. So instead of just giving you these vague ideas of what to expect, let's get into our examples so you can really see what I mean. Okay, so our first example, and as you can see, I typed these out beforehand so I didn't have to write them out because my handwriting on here is pretty bad. So example 1, 100 students are assigned to be in 3 classrooms. How many students should be in each class so the numbers are as balanced as possible? Okay, so 100 students in 3 classrooms. So if we take 100 and divide it by 3, you're going to get 33 students with a remainder of 1, basically. So assigning 33 per class, 33, 33, and 33, only gets us to 99 students. So what we have to do is we have to throw that remainder into one of the classes. Okay, so we would say we have 33 in one class, 33 in another, and 34 in the last, because that equals 100, and this is as balanced as we could possibly get. So that's how we used our remainder in that case. We just threw it in with one of our groups of 33. Okay, so that's one way that you'll use remainder information in a situation like this. So let's look at another situation. Matinee movie tickets cost $8. Jim has $30, so how many tickets can he buy? So let's take $30 divided by $8 to find out how many tickets he can get. So 8 goes into 30, let's see here, 3 times. All right, 6 left over. Let's bring down a 0. 8 goes into 67 times. Look, I've run out of room already. 8 goes into 45 times. So he could buy 3.75 tickets, but can you really buy 75 hundredths or a ticket or 3/4 of a ticket? No. So really we're going to look at our whole number and say that he could buy 3 tickets. This is a case in which we wouldn't round up. We can't say he could buy 4 because 4 tickets would cost $32, and that's not how much money he has. Okay, so you're going to have to be careful. Sometimes you have to round down even when numerically you would round up because he can't buy more than he has money for. All right, so he could only buy 3 tickets, and then with his extra money, maybe he can buy a treat. All right, example 3. 15 children need a ride to the fair. Each car can transport 4 children. How many cars are needed to transport the 15 children? So let's take the amount of children and divide it by the number of cars. Okay, so this is the original problem. We know we get 3 3/4. Once again, can we have 3 3/4 cars? No. What if we only had 3 cars? Then we could only transport 12 children. So in this case, we're going to need to round up and say we need 4 cars. Okay, because that will transport the at least 15 children. All right, so this is the situation opposite of the last one. The last one we had to round down. This one we have to round up because we need more cars in order to get the children to the fair. Okay? Example 4, Dale cut a 10-foot board into 4 equal parts, 4 equal lengths rather. How long was each of the 4 boards? So this one we're going to need an exact answer. 10 divided by 4. So 4 goes into 10 twice with 2 left over. So let's write this one as a fraction, 2 2/4, which equals 2.5. So each length of the board is going to be 2.5 feet long. All right, we wanted that one to be exact. We don't want any rounding here because we want to know exactly how many pieces, lengths of the board we have. So that's why that one we would just leave our remainder as is. You could have also written this one as a decimal. That would have been very precise as well. But I wouldn't have wanted to see the letter R in this case. We wouldn't have wanted to write, 2R2. That doesn't really mean anything in terms of length. 2R2, what does that mean? So you wanted either a decimal or a fraction here. Okay. Example 5. So I think this is our last example. Kimberly is on the school swim team. At practice, she swam the 50-meter freestyle 3 times. Her times were 37.53 seconds. Let's write that down. 36.9 seconds and 36.63 seconds. What was the mean of her 3 times? So you have to remember here that mean is the same thing as average. So what do we do when we need the average? We have to add up these 3 times and then divide it by 3 because it was 3 times. So add those all up, and I'm not going to go through the pretense of adding them up with you. I'll just tell you it's 111 and 600ths. So we'll take 111 and 600ths, and we will do the division part together. Okay? 3 doesn't go into 1. 3 goes into 10 3 times with a remainder of 1, and bring that 1 down. We've got 3 times again, and before I forget, let me put that little decimal in here. All right. Oh, look at this, guys. This is great that I'm doing this with you, because 3 times 3 is not 10, it's 9. Thank you very much. All right. That was close. 3 goes into 21 7 times. Can 3 go into 0? No. 3 goes into 6 twice with no remainder. So our mean time is 37 2/100ths, or 37.02 seconds. So this was another situation where we wanted an exact number. A decimal was going to be our best way to visualize that number, as opposed to fractions in this case. All right. So something different that we're doing with this lesson is that I am not going to walk through the practice set with you, unfortunately. What I'm going to do is I'm going to require that you fill that out in Google Classroom. And that's just so I can make sure that you guys understand the lessons. So please make sure you find your way back to the Google Classroom. Under lesson 111, you'll see the practice set. All right? Let me know if you have any questions.